Check this one. See, sometimes we will get these types of questions which are too big to simplify. So that's the reason we have different approach to solve this one. Previously I have given fx square instead of fxx. Okay, that is the formula which you need to remember. Or you can write this as f by y. Now, function f equals to ax square plus 2hxy
plus by square plus 2gx plus 2fy plus c equals to 0.
No need to consider 0. Function we have to consider. Equation we are not taking. So by saying this, we need d square y by dx square. In partial derivative, formula becomes in this way. fxx fy. One way is direct way which you have done in intermediate. Differentiating both sides with respect to x, then we will get dy by dx. Then again differentiating with respect to x, then you will get d square y by dx square. In that way you can substitute dy by dx into it. Lengthy equation you will get. Or else this formula you have to remember, d square y by dx square. What is the formula?
Minus fx
Minus of fxx.
fy whole square minus 2fyx fy
In place of
fx
fy,
plus fx whole square
yx is xy in this case. You can consider yx or xy, but it is given in the question yx, so you can write fyx, then fy, then fx. These are partial derivatives. So by saying that, we get to know that we have to find fxx, fy by fyx. Three double functions. Then single functions are fx and fy. So we will differentiate partially on both sides with respect to x. Differentiating partially with respect to x on both sides. So we will get fx here. Dou by dou we are doing. So a into 2x. 2x. Here x we have to differentiate. So this is 2hy
plus 0
0 plus 2g 0 0. This is fx. Then again we have to write this function differentiating partially with respect to y. So this becomes f becomes fy equals to 0 2h x y differentiation is 1 2by plus 2f differentiated. Now this one differentiating partially with respect to x. Again differentiating partially with respect to y. Dou by dx of fx is fxx 0. OB. Okay. Now fyx. Fyx equals to this one, dou by dou y of fx. This y we are taking outside, so dou by dou y of fx. So fx is here itself.
Sir, that is fx.
Here. Machine y wrong, wrong.
2h.
With respect to y, na?
2h.
This is 1, this is 0, 0. 2h. Any other thing we have in that one? All terms are covered. So we have to write now d square y by dx square equals to, I am not writing formula once again, same formula, minus of
2a.
2a.
2hx plus 2 of dy plus 2.
So what we'll do at the time of writing that function, we'll reduce one step by taking 2 common. So we'll consider a square bracket here. 2 common.
hx plus dy plus f.
Whole square is there, so square will get for both. Then
Minus
next.
2h
Yx is 2h.
fy.
Fy.
2ax plus 2x.
F. Then we have fy. Sorry, fx.
Again 2 common. ax plus hy plus g.
Plus fx whole square.
Plus
2 common.
ax plus hy plus g whole square. Fy 2b into 2b
F double 2.
by 2hx plus
2 into
plus whole cube.
if we'll take C, in this way we are doing 2x plus 2y is there, whole cube is there. So we can take 2 common inside the bracket, then whole cube. Cube is distributed. So writing the whole thing 3 times, because lengthy function we have reduced in that way. Got it now? Now what we can take common from the numerator? 4 or 8?
8 sir.
4 2 10 8. Here we can have many terms, so 2 to the 4 to the 8.
4 to the 8.
8 is there. So 8 common and cancelled. Remaining terms we will write now. Minus of 8 already gone. A into A plus B plus C whole square. A square plus B square plus C square plus 2AB. 2BC.
dy by 2fx.
This is the first one. A is outside, this 2 and 4 gone. The simplification is over. Then 8 minus h is there. And 2 is there. Minus 2h is outside. Into these two multiples. Hx is multiplied to all the values. Alphabetical order you can follow. You can easily get that. Hx into hy. Hx we are multiplying to first one. Hx we are multiplying to second one. Hx will multiply to third one. Ghx plus second one. By is multiplied to first one. Abxy. By is multiplied to second one.
dhy square.
Then by is multiplied to third one.
bgy afx
Plus
afx
plus fhy
plus df
this is also 1. Then we have plus 8 already outside and cancelled. B is there.
abx
By abx. Whole square is there. We can't multiply. We have to do same thing. A square plus b square plus c square. 2ab. These two with 2. 2ahxy. 2ghy plus 2agx. This is not sufficient to do this. Two cube is gone already. See, half of the answer we got already. Now that simplification will give that part because minus 2h is there, no? We will adjust here. Afterwards, after multiplying, you can write answer because after multiplication only terms you have to arrange. So first we will multiply a to all the values. Minus we will take now itself. Okay. No, minus into minus is plus. How we are getting that minus sign? Don't cancel anything. Just write answer after this step. See what we have to do. Actually, we have to take common. Ax square. Now where is ax square? So minus h square you have to take common first. After taking minus h square common, you find all those terms in the bracket. Make it 0. Then we will get the remaining part. If you want that, we can also do that same. H square we will round up first. Just I will show where we will get the answer. H square, wherever you find h square, round up. Only whatever terms which h square is there, we can take common.
minus 3h square y square.
6 terms are there, na? If you take minus h square common, you will get ax square plus simplify and you can check that whether we are getting answer or not. Show that to me afterwards. The 2 pages problem have been changed to 1 page, na? Answer for d square by dx. After multiplication, you can write answer also. So,
In test this we write like that with your mask.
it is there in that. Second unit I am not giving you. For final I am saying this. I give marks. Final also you get marks. You want the direct method also?
Same question. Same question.
It is there in book.
Sir, for today no music.
See what they have mentioned here. Z is equals to xy, f of y by x. Then z is a constant in this. This total function I am taking as this z comes here becomes minus x. Total function we are taking. Function means whatever term is given to you, make it equal to 0. So we will extend that to the right side. This we are taking as a function. Already f is used in that one, so I am taking f but in terms of capital letter. So differentiating partially. Why? Why we are doing that one? Because we find dy by dx here. Minus fx by fy with respect to x. So this becomes
You said just now with respect to y, sir.
why we are doing that. Y means that y, why. Differentiating with respect to why we are doing that one. That means that y is why. fx equals to, see when you find such functions quite difficult to do that, so you can write first as it is. Dou by dou x you can apply to both the values. Here we are differentiating x, so y is a constant multiple outside.
F is a constant.
F, this is a function. If you are differentiating or partial differentiating any function, it becomes dash. Whatever value is there. Suppose d by dx first we will take, f of 2x plus 3 is there. To differentiate this one, f becomes, this we have total single value. F becomes f dash of x. In place of x we have inner function derivative. Partial derivative also derivative itself. Okay, you write once again these two terms. Yes, u will form. Very good. This is 0. Y into bracket u will form. U derivative of this one. F dash of y by x inner function derivative. Plus u derivative of v plus v dou by dou x of x. Got it? How we have differentiated? In that first unit, one problem is there, na? Based on this type, you will get that problem function. In theorems, we will use this. I have left theorems for you. Na? One time we will do. In theorems, we will differentiate function in this way. If you are differentiating f, yes,
Can you explain these 2 steps once?
these two steps. See, dou by dou x we are taking to this. This is u and this is v. Y outside square bracket, u derivative of v. If you are differentiating this one in that way, f becomes, if you are differentiating total function, f becomes f dash, inner function as it is, then inner function derivative will take this y by x. Then u derivative of v is over, plus v. V is this one, derivative of u, dou by dou x of x. Next step we have y into
x dash y by x. Y into minus 1.
y into minus 1 by
Minus
x
1 by
square.
x.
How you got this? See, y is a constant. 1 by x. 1 by x is minus 1 by x square.
Plus f into y by x 1. Y into
Okay, if you want to write one more time, we'll afterwards we can do that.
minus f dash y by x.
This is fx. Now we do the process, we will find fy directly. Okay, we will write first f equals to differentiating partially with respect to y. Fy, y is there, so we have x is constant. U derivative of v, inner function also done, plus v derivative of u. Okay, that is a constant mentioned in the question itself. This x first we multiply, then we will cancel. This is fy, second one. In next step, now we need dy by dx. Why we have to find fx and fy? Till now we have not got that dy by dx. dy by dx equals to
minus f of x
x by fy. Dou by dou x of f, dou by dou x of y. Minus of. So minus will apply to both the values. Whatever we have. To avoid one step, we will go. Divided by. Now we have to check answer. It looks quite similar, no? We have dy by dx term. We have these values. Now by seeing this question, analyze that one. What we have on left side, f dash of y by x. So wherever f dash of is there, here two terms are there. Then f y by x, two terms are there. We have to take common by cross multiplication. We will get this. How we will get that? We will get to know now. Now we will cross multiply this. If you cross multiply this one, first we will write that function, then dy by dx at the end. First also you can write your list. Equals to what we have done in this step, cross multiply this value to this one. Now take all the terms to one side. Why we are taking that one? F dash we need in the numerator. So f dash of y by x is here. And f dash of y by x common. So what you will get on left side? This comes to left side minus sign into nothing. Then that step you want one step directly. Now f of y by x is there, you can send to right side. So already this is there, both are minus. So minus of f of y by x common. If minus f of y by x common, here what you will get? Y. From there if minus sign becomes positive, then x into dy by dx. Now f dash of y by x divided by f of y by x y square by x. Minus sign multiplied to the denominator. This minus sign multiplied, so this becomes negative, this is positive. Okay? X comes to numerator. Y is there. X, y is there, okay? Y is common, so we got this value x into y plus x dy by dx, y into y minus x dy by dx. This is the value for type of also function questions are there. Theorems are as it is, similar type of things we need to try. So what we have done by seeing that question, we need dy by dx. To get dy by dx, what we will do? Minus f of x by minus fx by fy. Once we get this one, both answers, fx you have to find, fy we have to find. Once we get two answers, divide them. By seeing that question looks similar to it, but the thing is f dash of y by x and by f of y by x are there on left side. To get that one left side, we have to cross multiply, taking common, then take that right side value to the denominator, minus sign as it is over there, send this to denominator, minus is applied to denominator, terms are reversed, then we have not got answer till here. What you have to do, if you don't want to do LCM, you can write answer, or else take LCM, x into 1 is x, this one x goes that side, xy, then this denominator of denominator comes to numerator, it is x into so on, then we have y common in this one, y common, this is y, already this x is here itself, y is there, so we will get the answer.